Hey guys, Dr. Brown here, and tonight we've got Calculus 2 where we're looking at integration where there's natural logs involved. So let's get after it. Okay, we have a few simple versions early on and we'll get a little more complicated as we go along. But you recall that we have an integral of the derivative of a function over a function. That's the definition for natural log of x. Okay, so when you see something like this, by definition you could think, well, that's 5 times natural log x plus c. So those become really easy, just like this one here. Let's let u equal 2x plus 5. du equals 2 dx. Okay, so now if we divide both sides by 2, du over 2 equals dx. So now we have, what do we have here? We have the integral of 1 over u and dx is replaced with du over 2. So I'm going to put that 1/2 outside here. Okay, so what do we have now? The derivative of a function over the function. So that equals 1/2 the natural log of u, which is 2x plus 5 plus c. Okay. All right, let's see. What do we have here? Now you can notice immediately with what's in the denominator, if you take the derivative of the denominator, you get 3x squared. So I know I can do something to eliminate that x squared. So let's let u equal 5 minus x cubed. du equals the derivative of a constant is 0. So I end up with minus 3x squared dx. So du then is, divide both sides by minus 3x squared, that equals dx. Okay, so what do we have here? We have, let's say u, 1 over u. So u is down here. We still have our x squared up there. But we're replacing dx with du over minus 3x squared. So du over minus 3x squared. The x squared term cancels, so we're left with minus 1 over 3, the integral of du over u. So minus 1/3 natural log of u, which is the absolute value of 5 minus x cubed plus c. Okay, so far so good. When you hear different people or different teachers talk about studying, they'll always tell you know your derivatives. Integration in calculus is all about the antiderivative. Well, to be able to flip it from one side to the other, you need to understand the derivative to start with. All right, let's clean up a spot to work here. Okay. Well, let's just get rid of some of them. Make a bigger spot. Okay. This one here. When you talk about know your derivative, if you just look at the denominator, what is its derivative? 4x cubed plus 3. Oh, 4x cubed plus 3 dx. So if I said u is what's in the denominator, if I just said, well, u equals x to the 4th plus 3x, du equals 4x cubed plus 3 dx, okay? Then du divided by 4x cubed plus 3 equals dx. Now I didn't learn when I went through school this. I learned, this right here. I would see that 4x cubed plus 3 dx equals du, and I would just erase that and write du. I think it's a better way when you isolate the dx, because many times you may just have a 1/3 or some simple fraction that you end up leaving off if you don't go through this method. So I like this. Isolate dx and then look at the terms. What do I have? Well, I have u in the denominator. I have this same 4x cubed plus 3 still in the numerator. And then I'm replacing dx here, this dx with du over 4x cubed plus 3. They cancel, and I'm left with the integral then of du over u, which equals the natural log of u, and u is x to the 4th plus 3x plus c. Okay? Not so bad. This one here. How to handle this one? Well, since you only have one term in the denominator down below, you can put that term under each one of these. So I would have the integral of x squared over x dx minus 4 the integral of dx over x. Ooh. X squared divided by x. We can simplify that. It's just x. So now I have the integral of x dx minus 4 integral of dx over x. So this is raised, x to the 1st plus 1 equals 2 divided by the 2. So I have 1/2 x squared minus 4 natural log of x plus c. Now you could, if you wanted to rewrite this, you could say 1/2 x squared minus the natural log of x to the 4th plus c. Be the same. You recall the rule when you say a to the n, a raised to the n, then you take the natural log of that. Well, that's n natural log a. So opposite of that is if I have this, I can convert it into that, which is what we've done here. We went from this to that. I don't normally do that. I'll leave it in that term. It seems a little simpler in my mind, but just know that it's available. All right, I'm going to pause the video and bring a few more problems out, and we'll start back in just a moment. Okay, I'm back. This is a cool problem here, I think. You'll enjoy this one. All right, we have the integral of the 1 over square root x times 1 minus 3 square root x. What to do here? Well, when I worked this the first time, I had no clue, but I thought, well, I'll have a few more terms here. Let me just guess and let u equal 1 minus 3, and I'm going to change this square root of x to x to the 1/2. So that's u. Well, du then equals derivative of a constant's out. So I have minus 1/2 3x to the 1/2 minus 1. So 1/2 minus 2 over 2 gives me that to the minus 1/2 dx. So isolating dx, as we mentioned earlier, is du divided by minus 1/2, well, it's minus 3/2, I should say, 3 times 1/2, minus 3/2 x to the minus 1/2 equals dx. Well, if I'm dividing this by negative 3/2, what does that mean? That's a negative 2 over 3. And then x to the minus 1/2, let me flip it up to the x to the 1/2. So I'll just put it up here. du equals dx. You can already see how this is going to work out. Now, I have the integral of, I'll put this minus 2 over 3 to the outside. I have x to the 1/2 du, so put this outside, x to the 1/2 du over x to the 1/2. u, and we've already replaced dx with x to the 1 minus 2/3 x to the 1/2 du. Wow, this cancels. Minus 2/3. So the integral of du over u equals minus 2/3 natural log of u, and u was 1 minus 3 square root x plus c. That's kind of a cool problem. Did I get it right? I have to look. Yep. All right, we're good. You can see some of the problems on the edge. I always write the answers down just to make certain I don't give you bad information, or if I do, I can catch myself and let's go back and see where we went wrong. Okay, a few more here. Hopefully everybody's had a wonderful day and you've studied and you've learned. This one is interesting. We have the integral of x times x minus 2 over x minus 1 cubed dx. What to do here? Well, since we're dealing with natural logs, I'm going to guess maybe I take and let u equal x minus 1. Now if I do that, du equals dx. Oh me, I'm just going to replace dx with du. I still have these x terms up here. What to do about them? Well, we could rewrite, add 1 to both sides. U plus 1 equals x. Okay. So let me put that in here. Integral of, I'll replace this x with u plus 1 times x is u plus 1 minus 2, which would be u minus 1, divided by u cubed du. We're replacing du is equal to dx. Well, let's see here. Why don't we just multiply this out and see what happens? Okay, so we would have the integral u squared, u plus 1, u minus 1, that's u squared minus 1. Yeah, so u squared plus u minus 1. Yep, so the u's cancel. U squared minus 1 over u cubed du. So that would give us, if we separate these terms out, I would have u squared over u cubed du minus the integral of 1 over u cubed du. Okay, u squared over u cubed, I have 1 over u. Let's go here. So I would have the integral of 1 over u du, I'll put the du here, minus the integral of u to the minus 3 du. So we just brought this u cubed to the numerator. So what do I have here? Natural log of u minus, so you add 1 to this and divide by it, so that would be a negative 2 divided by negative 2. That make negative negative makes this a positive. So this would become u to the negative 2. Also I've got this 1/2 here. 1/2 u to the negative 2, which would make that 1 over u squared. Alright, so natural log of u is x minus 1 plus 1 over 2 x minus 1 squared plus c. Let's see if we got that one right. Hey, right again. One last one and then we'll stop. Alright, this one is all about knowing your derivatives. the integral of cosecant squared x over cotangent x dx. Well, you have to know derivatives for sure to do this one, because what is the derivative of cotangent of x? It's minus cosecant x. So if we said u equals cotangent x, du equals minus cosecant squared x dx. Chain rule, almost forgot that. So du over minus cosecant squared x equals dx. So now we have the integral of something over u, so we have cosecant squared x over u, and we're replacing dx with du over minus, I'm going to put the negative outside, cosecant squared x. So these cancel, and I end up with minus the integral of du over u, and that equals minus the natural log of u, which was cotangent x, plus c. Okay, these were some problems we just snagged out of various textbooks, trying to show just a wide variety of how to use natural logs, how they're used in integration. Had a lot of u subs here, had trig identities we needed to understand, derivatives of trig functions. So there's a lot to remember, especially in integration. And a lot of that is know your derivatives. Okay, why are we doing this? Together we're trying to build a better tomorrow and do that through math. Keep studying, guys, okay? That's all for now, and we'll talk to you next time. Thanks.